Okay, so here's an example from the book. It's on page 455. And it's trying to determine if a sample is unusual. So a college phys ed department asked a random sample of 200 females. So N is 200. Pretty big sample, way bigger than 30. So it will overcome any skewness in the population, whatever that population is. So they're going to self-report heights and weights, but the percentage of students with body mass indexes over 25 seemed low. One possible explanation may be that the respondents shaded their weights down a bit. The CDC reports that the mean weight of 18-year-old women is 143.74. Right, so that is your population. The actual N is 200. The population average is 143.74, and the standard deviation of the population for weights is 51.54 pounds. But these 200 randomly selected women reported a mean weight of only 140. All right, so they took a single sample and got 140. Right, the population average is 143. So the question becomes, is this sample average unusual based upon this number here? So if you, at random, collected 200 women and weighed them, found their average weight, okay, is this 140 unusually low when you'd expect an average of 143? So first thing you gotta do is you have to build the distribution of X bars. That's this guy right here. See if I can make it a little bigger. I guess not. All right, so first off is our sample good. Took it at random. 200 is way less than 10% of all college female students. And is it large enough? Yeah, 200 is way bigger than 30. Okay. Now, this is not the population distribution. This is the sample means. But things that occur in nature, height, weights, stuff like that, are usually approximately normal anyways. So sample size wouldn't really matter. Okay. So we now say, okay, large enough is good enough. So all right, that's what he's saying right here. The distribution of college women's weights is likely to be unimodal and symmetric, no matter what. So the central limit theorem would apply even for small samples. 200 is plenty. All right, so we calculate the standard deviation, take the population standard deviation, divide it by the square root of sample size, get the standard deviation, and the average of all sample averages is the population average. So here's the distribution of sample averages for samples of size 200. This shape will change based on sample size because of this formula here. So we make this, and now I say, okay, here's basically 140. Is that unusual? Well, it's not 2 standard deviations away. It's a little more than 1 standard deviation away. So it's not unusual. It does not appear to be unusual. All right, so there's a typical problem.